Hey, surprise, surprise. It looks like the exact same learning target as the previous lesson, where we'll be dealing with rational exponents. Of course, the denominator of the exponent will tell us to take a root, and the numerator of the exponent will tell us to raise our answer to a power. Let's see what's different today. All right, so this is what we've been doing, something like 16 to the 3/4 power. It's like, hey, I need 4 equal factors that multiply to be 16. And so that, of course, will be the number 2. All right, 2 times 2 is 4, times 2 is 8, times 2 is 16. So if I take the 4th root, I'll just have a 2. And then I can raise that 2 to the 3rd power. 2 times 2 times 2, which is 8. And again, if you can manipulate this in your head, that's fantastic. Please show some work on paper, however. Or if you need to use the exponential table, that's fantastic. But again, please show on paper what numbers are being used. Or if you need to use a calculator, go ahead and use a calculator. All right. And again, 3/4, the exponent is less than 1. Therefore, our answer of 8 is less than that base that we started with, which is 16. With the disclaimer, once again, that while 3/4 is less than 1, it was also greater than 0. And of course, I used 3 of the 4 equal factors to get our answer of 8. Oh yeah, this is like those incredible offers. All right, we're going to double the offer, no additional cost. And unlike the commercials you hear about, we're not even going to have you pay anything for the shipping or handling. What if the rational exponent happens to be negative? Right? You thought it's fun having a fraction for an exponent? We can have a negative fraction. That's the new twist today. So the positive exponent tells us how many times we're going to multiply by an equal factor. Instead of negative exponent, guess what? Instead of multiplying, we're going to be dividing. So instead of having a bunch of equal factors, we're going to have a bunch of equal divisors. So if I have 2 to the 4th power, you say, hey, that's a piece of cake. I just have 4 2's and I multiply them together, I get 16. But if I have 2 to the negative 4th power, that's a little bit different. So, oh, I have to divide by 2 4 times. So I'll have 1 over 2 times 2 times 2 times 2. In other words, 1 over 2 to the 16. Another way we can think about this is we're like, hey, if I got 2 to the negative 4 power, and I'm not comfortable dealing with that negative exponent, I can make that negative go away real quick. I can put 2 to the 4th power in the denominator of a fraction. Right? I've got 1 over 2 to the 4th power. And now, instead of trying to think about dividing by 2 4 times, I'm like, hey, 2 to the 4th power, I know how to do that. I'm going to multiply 4 2's together. And so now I can actually think of it as multiplication, because my brain works a little bit better if I think about that with an exponent. So, hey, I got to take the number 2. In fact, I need 4 of them. Multiply them together, I get 16. And of course, the 16 is in the denominator because originally the exponent had a negative on it. All right, so let's take a look at a couple. We always want to start by, if there is a negative on the exponent, take care of the negative first. Then take care of the root, and then take care of the power. I don't have to go in that order, but if I do the power first, the numbers get really large. So I want to do the roots before the powers. Okay, so if I see a negative exponent, I can get rid of the negative by placing the 625 to the 3/4 power in the denominator of a fraction with 1 as the numerator. Now I can take care of the roots. I got to take the 4th root of 625. Some of you might actually be able to do that in your head. Some of you will say, no, let me grab the exponential table and I'll line up 625 with a 4. And I can see that it would boil down to 5, right? 5 to the 4th power is 625. Or you could use a calculator. Now I have to raise it to the third power. 5 times 5 times 5 is 125. 343 to the negative 2/3 power. Okay, again, the negative on the exponent says, hey, do the reciprocal. Put a 1 on top, put the 343 to the 2/3 power on the bottom. I no longer have a negative exponent. Take the cube root of 343. Well, that's just 7 times 7 times 7 is 343. So now I just have 7 squared. 7 times 7 is 49, so my answer is 1 over 49. I think we got one more example coming up here. 121 to the negative 3/2. Okay, want the negative to go away? Reciprocal, 1 over 121 to the 3/2 power. I need the second root of 121, which is going to be an 11. Now I need 11 to the third power, which is 1,331. And of course, that is a denominator. Notice that even though the exponent is negative, the answer is a positive number. Right? A negative exponent creates a reciprocal. It does not create a negative number. Right? If the base was originally positive, the answer will be positive. Doesn't matter if the exponent is positive or negative. And now you might also see why before I was talking about when an exponent was less than 1, that it was also greater than 0, because interesting things happen when we are less than 0. And I don't know why I thought this was funny, but I did. You think, hey, at least there aren't any cows.